Hello, good morning everybody. Today we are going to discuss about the construction of minimum weight spanning tree using Prim's algorithm. If there are n vertices in a spanning tree, there will be n minus 1 edges. This is very important thing we have to keep in mind. A spanning tree is a tree connecting all the vertices of a given graph. Now let us start with an example. Consider a graph having edges, having the vertices A, B, C, D, E, F, G, and they are connected with number of edges. So in our process of starting with, in our process of constructing the minimum spanning tree for this graph, first we start with any vertex. Any vertex, you can start with C, A, B, any of the vertex, and then make that vertex as the starting point of the tree. Then choose the next vertex which is nearer to that and then form an edge. Now there are two vertices in the tree with an edge. Now go on picking up the vertices which are nearer to the tree nodes, breaking the ties arbitrarily whenever it comes. So this process should go till there are n minus 1 edges, or you say till all the vertices have been taken into the graph. Now beginning with, if you want to start with a vertex D, so now I am beginning with vertex D. So there are number of vertices. DB is 1. The vertex D is connected to all the vertices. So D is connected. So the minimum of the one is, you can say DB or DF. So I take the edge BD. So now this is my spanning tree, beginning the first stage. So this edge has been now considered. I am starting with D. So then the vertices which are nearer to D and B, so there are number of vertices, but beginning with D there is one vertex F which is distance 1. But if you go with B, the vertices, it is connected to A, E and G. Its weight is 3, its weight is 3, its weight is G, its weight is 2. But the connecting with the D and F, it is only 1. So in the next phase, I take F into consideration. So this is already there. Now I am going to add this vertex. Thereby this is already existing. This is what I have included into the graph just now. So next vertex I need to choose is, this is picked up and this is also taken. Now for this graph, 3 vertices are already present. Then you need to choose the next vertex which is nearer to these things. So here already this is already formed. Now I have to go for the next vertex which is nearer. So if you go for this B to G, that is 2, and D to A is also 2. 2 B to A it is 3, D to A it is 2, B to G it is 2. So now you can choose a vertex of your choice. Either you can take G or you can take A. Now I take into consideration the vertex A. So this I am taking. So thereby what happens is, now my minimum spanning tree is this. So this is present, this is present, and this is present. So the weight of it is, the weights we have already discussed. So this is 1, its weight is 1, its weight is 2. So as the next step, pick up the next vertices which are nearest to the tree edges. Now the tree vertices. Now the vertices of the tree are A, B, D and F. So the next one, this is picked up, and the next one, it is either you can go from A to C, which is 2, or you can take the edge, this edge, which is of distance 2, right? So right now these are the two things. These are the two edges. Therefore I can go for C or I can go for including G. So now what I do is, I go for this including this edge C. So this I would like to draw. So now if I am going to draw that particular edge, it looks like this. So I have already joined this, this is 1, this is 1, and this is already present of 2. Now I am going to add this edge, the cost of which is 2. Now there are 5 vertices in the graph. There are 5 vertices in the graph. Next, now this has also been considered. This is taken 1, 2, 3, 4. Now this is also considered. I said breaking the ties arbitrarily. You can choose from D to A or you can choose B to G. I have taken this. Now the edges of the tree are 1, 1, 2, 2. Now pick up the vertex which is nearer to the tree vertices. Now if you observe, from F to G that is 4, from D to G it is 3, from B to G it is 2. So my next choice would be taking B to G. So I'll connect this B to G because the weight is less. So by now you'll have so many edges connected. This is connected, this is connected, this is connected, and this is already connected. This is my new edge. This I am connecting. So this is the spanning tree till now. So next, this is the only vertex left over. So I look at the nearest distance. So the nearest distance is G. Therefore I connect it. So this is this I am connecting, and hence my new graph, the graph, for the graph this is what my minimum spanning tree. So this is connected, this is connected, this is connected, and this is connected, this is connected, and this is connected. If you look the weight, 1, 1, 2, 2, and 2, this is 1. So if you look at our graph again, so as I said, this is 1. So this is the minimum spanning tree using the Prim's algorithm. One important thing what you have to keep in mind is, for a given graph there can be number of spanning trees, there can be number of minimum spanning trees. For example, when it was a choice of selecting AC and BD, you have taken this. So the minimum spanning tree is constructed, and when you talk about the cost of it, it is 2 plus 2, 4 plus 1, 5 plus 1, 6 plus 2, 8 plus 1. So 9 is the minimum cost of the spanning tree. Thank you. Thank you once again.